Picture this, a sun-like star, much like our own, gliding peacefully through the vastness of space, minding its own business. For years, astronomers watched it, charting its predictable path, but then they started noticing something peculiar, a subtle, rhythmic tug, ever so slightly pulling it off course. It was as if an invisible hand, 10 times heavier than our sun, was locked in a graceful 186-day waltz with it. No light, no dramatic flares, no X-ray fireworks, just pure, unadulterated gravity at play. This, folks, is how we met Gaia BH1, now officially the closest black hole ever found to Earth. What makes it even more intriguing is that it isn't aggressively gobbling its partner star. It isn't spewing dangerous X-rays across the cosmos. It's just there. It's the cosmic equivalent of discovering a massive, sleeping dragon curled up quietly under your porch. Do we dare to wake it? Do we simply ignore its silent presence? Or, perhaps, should we start packing our bags and moving house? Section 1. How do you find something that swallows light? It's a truly perplexing question, isn't it? How do you even begin to spot an object that, by its very definition, swallows every photon of light that dares to cross its event horizon? Gaia, the European Space Agency's incredible stellar cartographer, doesn't actually see black holes directly. That's simply impossible. Instead, Gaia is a master of precision, meticulously measuring the positions, distances, and movements of billions of stars across our Milky Way galaxy with hair-width accuracy. It's performing the most detailed census of our galaxy ever undertaken. If a star, like the one orbiting Gaia BH1, starts to wobble or deviate from a perfectly straight path, it signals that something massive, something unseen, must be doing the tugging. Think of it like sitting on a swing set. If you suddenly feel an unseen friend pulling the chains, you know there's a force at work, even if you can't see them. It's the same basic idea, just scaled up to a trillion-mile playground. After years of collecting incredibly precise data, the subtle wiggle in this particular star's trajectory grew undeniable, becoming a clear, rhythmic dance. What astronomers observed was a star, virtually identical to our own sun, orbiting an empty point in space, yet that empty point had a gravitational signature indicating a mass roughly 10 times that of our sun. The only known object that heavy and that utterly dark is a black hole. Bingo! Through this ingenious method of cosmic detective work, the closest monster was located, not by its presence, but by its profound absence of light and its undeniable gravitational influence. It's a testament to the power of indirect observation in astronomy. Section 2. Why dormant matters. The fact that Gaia BH1 is dormant isn't just a minor detail. It's absolutely crucial to understanding why we didn't find it sooner and why it poses no threat. When most people think of black holes, they picture the supermassive ones at the centers of galaxies or stellar mass ones that are actively feeding. These active black holes are dramatic. They glow incredibly brightly as they shred nearby gas and dust, heating it to millions of degrees, forming superheated accretion disks that emit powerful X-rays and even jets of material. They essentially announce their presence across vast stretches of galaxies with a blinding, energetic spectacle. Gaia BH1, however, skipped that party entirely. It finished its stellar meals eons ago and now drifts through space in quiet retirement. Without the telltale glow of a feeding frenzy, without those powerful X-ray emissions, the only fingerprint it leaves behind is its subtle, yet relentless, gravitational pull. This dormancy is precisely why it eluded our detection for so long. It also leads to a fascinating and slightly unsettling implication. If a dormant, 10 solar mass black hole can lurk this close, undetected until now, then millions of similar sleeping giants could be hiding across our galaxy, potentially much closer than we ever guessed. Statistically, there could even be others closer than Gaia BH1, simply waiting to be discovered by future, even more precise methods. Their silence is their camouflage. Section 3. The cosmic dance nobody predicted. Here's where Gaia BH1 really starts to shake up our understanding of the universe, and it's arguably the weirdest part of the whole discovery. The companion star, the one locked in orbit with a black hole, looks remarkably untouched. This is a huge puzzle. Standard models of stellar evolution tell us that the progenitor star, the massive star that eventually collapsed to form a 10 solar mass black hole, should have gone through a colossal red supergiant phase. During this phase, it would have ballooned out to an enormous size, likely engulfing its companion star entirely, or at the very least, frying it with intense radiation and stellar winds. Instead, what we see is a pristine, sun-like star, chemically normal, orbiting at roughly the same distance Earth orbits our Sun. It's like stumbling upon a perfectly formed, untouched snowman sitting right next to a recently erupted, still smoking volcano. It just doesn't add up according to our current textbooks. The survival of this companion star, in such a close orbit, has sent theorists scrambling. They're now desperately trying to explain how the star could have survived the violent collapse of its partner. Did the black hole form through a different, less destructive channel? Was there a complex triple star drama that somehow ejected mass in a way that protected the companion? Or perhaps the black hole's progenitor star lost a significant amount of mass before its collapse through some as yet unknown mechanism, preventing it from expanding into a destructive supergiant. This quiet neighbor is forcing astronomers to rewrite entire chapters of stellar death and binary star evolution, pushing the boundaries of our cosmic understanding. It's a truly exciting time for theoretical astrophysics. Section 4, putting 1,560 light-years into human terms. Let's be clear. 1. 560 light-years is still an unfathomable distance by human standards. To truly grasp the scale, consider this. Light itself, the fastest thing in the universe, racing at an incredible 300,000 kilometers, or 186,000 miles, per second, needs a millennium and a half, 1560 years just to reach us from Gaia BH1. If you were to hop aboard NASA's fastest outbound probe, Voyager 1, which is currently hurtling through interstellar space, you'd need roughly 25 million years to cover just 1 light-year at its current trundle. Multiply that by 1,560, and you're looking at a commute no species, not even the most advanced, is likely to be booking anytime soon. The good news for us Earthlings is that gravity, while a powerful force, weakens dramatically with distance. It follows an inverse square law, meaning its strength diminishes very rapidly as you move away from the source. By the time the gravitational pull of Gaia BH1 reaches us across that immense void of 1,560 light-years, its influence is literally billions of times weaker than the moon's gentle tug on our ocean tides. To put it simply, its gravitational grip on Earth is not just negligible, it's statistical noise, utterly imperceptible and completely harmless. You're more likely to feel the gravitational pull of a passing bird than you are Gaia BH1. Section 5, could it ever become dangerous? It's a natural question to ask, given the ominous nature of black holes. Could Gaia BH1 ever become a threat to Earth? For a threat scenario to even begin to materialize, Gaia BH1 would have to wander significantly closer to our solar system. However, stars and stellar remnants in the Milky Way, including black holes, drift through the galaxy like molecules in a very, very calm and incredibly vast gas. Their movements are slow and predictable on galactic timescales, even over billions of years, a timescale far exceeding the remaining lifespan of our Sun. The odds of this particular black hole approaching within even a few hundred light-years of our solar system are astronomically low, lower, in fact, than winning your national lottery not just once, but twice in a row. And let's not forget its dormant nature. Remember, this black hole isn't carrying a vast reservoir of gas and dust that could suddenly ignite a violent quasar-like event if it encountered our solar system. Without fresh fuel to consume and superheat, it remains a harmless dark mass, more akin to a cosmic paperweight than a predatory, destructive force. Its immense gravity is localized to its immediate vicinity, and the vast emptiness of space provides an impenetrable shield. So, rest easy. Gaia BH1 isn't coming for us. If unraveling the mysteries of hidden cosmic neighbors and understanding these incredible forces makes your brain light up with curiosity, then consider hitting that subscribe button. It costs absolutely nothing, helps support the channel, and ensures YouTube's algorithm is more likely to show you the next deep space story we uncover, rather than burying it. And please, feel free to drop a comment below. Does finding a nearby black hole like Gaia BH1 thrill you with scientific wonder? Or does it send a slight chill down your spine? We'd love to hear your thoughts. Section 6, why astronomers are celebrating, not evacuating. Despite any initial apprehension the word black hole might conjure, astronomers aren't packing their bags, they're popping champagne. Gaia BH1 isn't a harbinger of doom. It's an incredible gift, a natural laboratory positioned only 560 light-years away, This proximity offers an unprecedented opportunity to study a black hole system up close. Telescopes can now observe how starlight from the companion star bends ever so slightly as it passes near the black hole, allowing scientists to test Einstein's theory of general relativity with a level of precision that was previously impossible for such a system. It's a real-world experiment on the fabric of spacetime itself. Furthermore, this discovery refines our search techniques. Future missions might be able to spot other isolated black holes using the same microlensing trick, where the black hole's gravity briefly magnifies the light of a more distant star as it passes in front of it. This will help us fill in the missing census of dead stars across the Milky Way. Every new specimen like Gaia BH1 refines our theoretical models of how massive stars collapse, how binary systems survive such cataclysmic events, and ultimately, how many unseen bodies truly haunt the dark, vast spaces between the stars. It's a cosmic goldmine for researchers. Section 7. A galaxy teeming with quiet giants. Before the discovery of Gaia BH1, only a handful of black holes were confirmed within 3,000 light-years of Earth. Most of these were active black holes, detectable precisely because of the X-rays they emit while actively feeding on gas from a companion star. Gaia BH1, being dormant, changes the game entirely. If a dormant, 10 solar mass specimen can lurk this close, undetected until now, then population models suggest our galaxy could host tens of millions more of these quiet giants. Now, that number, tens of millions of black holes, might sound terrifying at first. But remember just how mind-bogglingly roomy space truly is. Even with millions of black holes scattered throughout the Milky Way, the average star would still be separated from its nearest black hole neighbor by thousands of safe light years. The sheer scale of the galaxy ensures that encounters are exceedingly rare. Think of it this way: our galaxy is a vast, untamed jungle, and while there might be many powerful tigers roaming within it, the jungle is so immense that direct encounters are incredibly rare. We're safe in our little clearing, and the vast distances between us and these cosmic predators provide the ultimate protection. Section 8. What we still don't know. Even with this groundbreaking discovery, Gaia BH1 leaves us with a tantalizing array of questions, pushing the boundaries of our knowledge. Did it form directly from the collapse of a single, massive star, or did it perhaps arise from the merger of smaller, stellar mass objects? Is it spinning near the theoretical maximum, dragging spacetime around it like honey, or is it lazily pirouetting through the cosmos? The precise timing of its companion star's orbit, observed over many years, may eventually reveal tiny changes that betray the black hole's spin, which in turn could unlock clues about its mysterious birth story. The scientific journey doesn't end here. Next-generation instruments, like the upcoming Nancy Grace Roman Space Telescope, could revolutionize our search. By monitoring millions of stars for those subtle micro-wobbles or microlensing events, these powerful telescopes might discover even closer dormant black holes. Each new discovery chips away at the unknown, turning yesterday's perplexing ghost stories of the cosmos into tomorrow's solvable textbook problems. It's a continuous process of discovery, refining our understanding with every new piece of evidence. So, there you have it. Gaia BH1 isn't just the closest black hole yet found. It's a silent, 10 solar mass heavyweight locked in an elegant, 186-day cosmic dance with a twin of our own sun. Its very existence appends long-held theories of binary star evolution, hints at the vast, hidden population of millions more dormant cosmic monsters, and offers astronomers a front-row seat to test the most extreme physics known to humanity. Should you worry? Honestly, not unless you plan to live for a few million years and somehow figure out a way to cancel the expansion of the universe. For tonight, Earth is incredibly safe. The skies are clear, and the dragon under the cosmic porch is still peacefully dozing. Let's keep learning, keep exploring, and keep understanding before it, or another one, surprises us again. If you enjoyed this cosmic check-in, please do like the video, share it with your fellow space-curious minds. And remember, space is vast, but with knowledge and wonder, understanding it makes it feel a little more like home.